So in yesterday's class, we discussed about uh, previously, that means in the last class or in yesterday's class, what I discussed with you about Bohr model, about a Sommerfeld model, right? Before that, in your ninth class, we discussed about the John Dalton proposal, that is Dalton theory or Dalton atomic model. After that, Rutherford atomic model is there, J.J. Thomson atomic model is there. Not only by them, many models are proposed by different personalities here, right? So several scientists worked on them, but they have failed to explain that why spectrum is given by them. Only they have explained atom which can form the spectrum having only one electron in them, right? Single electron atom spectrum is explained, but not by the uh, doublet. That means two electrons or more than two electrons. So no one explained. And many failures are there. Yesterday we discussed in case of a Bohr atomic model, like that heavy atoms spectrums, G1 effect, Stark effect, no discussion about the chemical bonding. So that means no discussion of a shape of the molecules. Likewise, many uh, contradictions are there. They were not discussed. So here, to understand about that one, they are continuously trying. So in that way, Planck's quantum theory helped. So what is actually Planck's quantum theory? Here, in the Planck's quantum theory, we are discussing about the radiation, especially by the black body, right? Especially by the black body. So here, simply, Max Planck proposed a quantum theory to explain the black body radiation. So radiation means heat energy, right? So that is transferred from one place to another place without any contact or without requiring of a medium. So why black body? It is the perfect absorber of heat, right? And it emits the radiation also. So a body which is perfect absorber and a perfect emitter of radiation, right? So a body which is perfect absorber and also perfect emitter of radiation, that is called as here black body. So in such case, that means in case of the black body, he observed the radiation. That means energy in terms of multiples of H. Constant is given. So why he used constant? Because he observed always the ratio of energy and the frequency. Right? From that, he introduced a constant called Planck's constant. So here, the energy emitted from a material body increases with increase in heat energy. So when you increase the heat energy, it can absorb much energy and also that emits the energy in the same manner, right? So that he noticed a material body which is completely black, so considered to be a black body that is observing the energy, heat energy, according to you are providing energy, then also emitting energy in the same way, right? So that is, he noticed here simply that discrete quantities means changing quantities, change in the quantities. So here, in what way you are increasing, in that way, absorption and emission also increasing. So that discrete quantities of energy is called as here photon. That energy is considered to be in a photon energy packets, quantized. So that quantized energy is named as photon here, photon energy, right? Photon means simply here in the form of light, right? So it's energy. That photon energy is directly proportional to the frequency, right? So light is considered to be in the form of electromagnetic waves. So we can describe that characteristics in terms of wavelength and frequency. So that is observed. Energy is observed in terms of frequency. So energy always observed, it is directly proportional to the frequency, right? So what we can say here, the ratio of energy and the frequency is always giving you a constant. That constant only here introduced as Planck's constant. Proportionality constant is introduced as now Planck's constant given by a letter h. So that h value is taken as 6.626 into 10 to the power of minus 34 joules. 6.626 into 10 to the power of minus 34 joules second. So these are the information we need to understand from the Planck's quantum theory. So this Planck's quantum theory helped a lot in understanding the spectrum given by the atoms, right? When they are introduced into a source of energy, right? Exposed to the strong source of heat and light. Because why you need heat and light? Here you are unable to see the particles. The tiny particles only called as here atoms. Directly you are unable to see, right? So here, simply to see them, you are required energy. Suppose if you went into a dark room, can you find anything without the help of light? No. We are able to see the objects only in the presence of light. So sometimes the particles already they have mass and occupying the space, but they are not visible to you directly your eyes, with your eyes, right? So in such cases, we required a strong source of heat and light. So that's why you need to understand here radiation, black body. So that helped in understanding the structure of atom, right? So here simply now we are converting our topic or changing our topic into quantum mechanical model. So from quantum theory to this concept changed, that means understanding of structure of atom changed to quantum model. So that quantum model now we are discussing. So what is actually quantum model? So this quantum mechanical model proposed by Max Planck, right? Quantum mechanical model proposed by Max Planck. Here, further, it was improved by another scientist, right? Another scientist that is improved by Erwin Schrödinger. Max Planck proposed a quantum mechanical model, but later on, it further improved by Erwin Schrödinger, right? So here it is helped us to understand the spectrum. Then the spectrum is also described with the help of electrons, depending on the arrangement of electrons, right? So before going that, we have many topics to discuss here. What they are here, do the electrons follow different paths around the nucleus as proposed by Rutherford or Niels Bohr or Sommerfeld? Rutherford, what he assumed a planetary model, right? In that, what he explained, electrons are revolving around the nucleus in a particular orbits, right? Then that orbit's particular shape is assumed by Niels Bohr as circular orbits. Later on, it was changed to another elliptical orbits, right? So whatever it may be, what is an orbit? What is an orbit? Here, orbit simply is selected the path maintained by the electron around the nucleus. What is an orbit? Orbit is a path maintained by the electron around the nucleus was named as orbit. So here that orbit shape assumed by Niels Bohr, circular. Later on, it is given as elliptical orbit. That is the different thing. But here, whatever it may be, shape of the orbit, here orbit is the path around the nucleus. Simple definition. The path around the nucleus, right? So here, do that electrons follow different paths around the nucleus? What you are understanding in your level? Do they maintain? Do they maintain definite path around the nucleus? Can anybody agree? What happens if they do not maintain particular path? Rohit. So no one able to answer. If there is no particular path, How you are able to decide that electron revolving around the nucleus? And one more, there is no particular boundary for the atom. Unlimited, right? So compulsory atom having with the particular boundary, that means existing of electrons around the nucleus in different parts, right? So we have, then if they are maintaining the definite path around the nucleus, are we able to find out the velocity of the electron? Do they move with a constant velocity? Right? So here, simply due to the attractions, repulsions, may not they maintain constant speed. Maybe it is not possible, right? Here, if you want to find out electron velocity, we need to visualize that electron. Can you see that electron around the nucleus? Only in the presence of a strong source of heat and light, we are able to see the electron. Directly, it is impossible. Okay. If you are able to see that, are we able to find out a velocity? Are you able to trace that path of the electron exactly continuously? Right? So here, electrons are invisible actually. Electrons are invisible. So here, how do you find out the position of velocity and position? Right? So here for that, we are depending on the source of light, because the particles which are very smaller, they can respond to particular wavelength of light. For example, in our day-to-day life, if you receive the light, what light? Sunlight, through any slit, through the hole into your dark room, you are able to see many dust particles floating in that beam of light. But once they cross the beam of light, you cannot visible that particles. Have you experienced this one? Have you experienced this one? Visible of particles in the sunlight, that which passing through a slit or gap into your dark rooms or into the room, or nighttime, if you switch on white colored torchlight in the dark room, you can see many particles, like they are moving as fumes. Have you experienced this one? No one? Yes. So here, simply like that, you are able to see the particle in the strong source of light, because they are responding particularly short wavelengths of light. Short wavelength of light. So by using that short wavelength light, we can find out presence of electron and that disturbance created by that. So you are able to disturb the electron by using this, because here it is what you are using the light. It is a source of energy. Automatically, it gives the vibration to the electron, because it consists of charge. So that charge may be disturbed by that. So likewise, you are able to find out. So here, using this, you are able to disturb the electron. From the this discussion, here you are able to answer electrons maybe follow the definite path, right? So here, if the electrons do not follow definite paths in an atom, do atoms have any fixed boundary? No fixed boundary. So without fixed boundary, how you can decide atom is a small particle? Is it possible? So that's why your assumption is correct, right? Our assumption is correct. Electrons are following definite paths around the nucleus, right? So here, under these circumstances, in order to understand the properties of electron in an atom, here quantum mechanical model of an atom developed, further improved, right? So here it is helping you to understand about the structure of atom completely, because you are able to locate a electron around the nucleus in a different paths. That paths are called as here orbits, right? If that is maintaining a completely what a fixed path and a fixed velocity, you are able to find out the exact position of the electron, right? But not exactly. It is impossible to find out the exact position of the electron at a particular instant because continuously it is moving. How you are able to decide that is exactly here it is at this particular instance? No one. We are unable to say that electron exactly existing at this point at this particular instant. But the probability is there. Maximum probability is there, right? To find the position of a electron in a region. So maximum you are able to see, right? So that where you are able to find out maximum probability of electron location, maximum probability of location of electron, that we are defining as here the space for the or region for the location of electron. That region we are naming as here orbital. So do atoms have definite boundary? Yes, as suggested by the Niels Bohr. Already we discussed about that. Then here, what do we call the region of space where the electron might be at a given time? So exactly it is impossible to locate, but maximum probability is there to locate the electron around the nucleus, right? That space or region we are now defining as orbital, right? So orbital is what? Simply it is a maximum probability of finding electron in space around the nucleus is called as orbital. So these orbitals here having the different shapes. Sir, why these orbitals only given by the shape? Is it compulsory to give the shape for the orbitals? If it is uh, compulsory to give a shape, how do they decide the shape of the orbital? Right? So here it is not like that. Here, the space around the nucleus, for example, if you assume this is as a nucleus, right? So something space is occupied by the electron to move in a definite path. So in this path, right? In this path, you are having maximum probability region. Suppose this region assumed. I'm not talking about the shape, just a space with a particular area assumed. So in that, if that electron visible as a particle, right? So that particle is giving you shape. So that particle's shape is given like this. So this shape is visible to you as spherical shape. If that space is like this given, so it is looking like a dumbbell. If it is given this shape as like this, so we can name these eyes differently. So observing these dots, how many times they're located in the region, they are taken the photographs. X-ray diffraction method. X-ray diffraction method. So by using that method, they are named the shape of the orbital here. Right? Any confusion? Am I giving you perfect or confusing? Are you with me? Yes. Right? So simply you are able to give the shape also using this radiation, finding the position. So orbital concept, right? So directly not they are giving the structure. They are understanding the location of electron first, right? So that concept changed to now orbit and orbital. So after that, in the quantum mechanical model, to understand about the electrons, we are depending on the numbers. So each electron in an atom is described by a set of 4 quantum numbers. Quantum means measurable, right? So we are able to measure it. So that measurable numbers are describing the electrons with a set of quantum numbers called here. They are, sorry, that which describes the electron called as quantum numbers, right? So that quantum numbers are here 4 types, majorly 3 types only, but later on, one more they are introduced, that is spin quantum number, right? So what information do the quantum numbers provide actually? Right? What the quantum numbers are providing the information to us? Here they are giving completely information about the electron, location of electron, where the possibility is there to find out that location, right? What is the shape, right? What about the orientation, how they are revolving or moving around them. So everything we are able to understand by using these quantum numbers. So particularly they are giving the address of the electron. They are addressing the electron in the atom around the nucleus, right? So quantum number significance is what? To address the electron around the nucleus within the atom, right? So here, what is the significance of quantum numbers here? To know about the energy, to know about the size, to know about the shape, to know about the orbital orientation, to know about the distribution of electrons, to know about the orientation of electron. So this much of information you are now able to give using these quantum numbers. So that's why quantum mechanical model successfully explain the structure of an atom, right? They are not said simply positive charges are located in the nucleus, right? Then electrons are revolving around the nucleus, not like that. So everything they try to understand, right? So that's why here we are giving much importance to the quantum numbers. So what are these quantum numbers? So quantum numbers are majorly four there. What they are here? Where they are here, principal quantum number, azimuthal quantum number, next magnetic quantum number, and spin quantum number. These are the four types of quantum numbers. We have majorly four types of quantum numbers. So that four quantum numbers are namely already I given you. What they are here? Principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. These are not proposed by only one member. Several scientists are worked together on this quantum mechanical model. So individually they tried, one by one they introduced and explained, right? So the very first quantum number is simply, okay, so significance of quantum numbers, simply to know about the size and energy. Not only the size and energy, they are explaining about the shape and subshell, sub-energy level, or the location of electron is nothing but orbital. So orbital. Next, they are explaining about the orientation of the orbital. Along with the orientation of orbital, you are able to know about the orientation of the electron, especially about the spin of the electron. How they are. Spinning means moving around itself, right? Moving around itself, called a rotation, right? So spin of the electron. As you spin the ball, as you spin the notebook on your finger, like that. So electrons also moving around the nucleus by moving around themselves first. As the earth is moving around the sun, moving around itself and moving around the sun. Like that, here electrons also moving around themselves, called spin, and moving around the nucleus, orientation of the electron around the nucleus, right? So both are there. Then here, now we are discussing about the quantum numbers here, right? So first one is principal quantum number. Principal quantum number. Here the first quantum number introduced. Here it is to simply proposed by Niels Bohr here. Principal quantum number was proposed by Niels Bohr. So he is the person on the screen. Niels Bohr proposed principal quantum number in his Bohr atomic model, right? So that quantum number he used to indicate the space where the electron is moving around the nucleus, called orbit. That is only named as stationary orbit, having with the fixed energy. So that's why here we are considering main energy level. The principal quantum number is considered to be main energy level. So how many energy levels are there around the nucleus? They are considered to be here simply orbits, and that orbits only giving the size of the atoms, right? So here it is used by the letter N or denoted by the letter N. This N particularly help us to explain about the size and energy of the orbital as proposed by Niels Bohr in his Bohr atomic model. So we are considering the orbit size main energy levels. So to indicate the energy of the orbital or about the atom, right, in terms of orbits, right, then here it is also help us to explain about the size. Then here simply that N values are given here. Sorry, print mistake. N values only takes counting numbers, natural numbers without zero. So N takes not with 0, 1 to infinity, right? 1 to infinity. So don't read here 0. N takes only counting numbers, 1 to infinity. Not infinity number required, 1 and so on. So 1, 2, 3, dash, dash, dash. Here, depending on the N value, here you are able to count the number of orbitals in the main energy level using N square. Suppose N equal to 1. N equal to 1. N equal to 1 indicating that main energy levels by using here N square value. Then if it is given by N value 1, 2, 3, 4, anyone, right, you are able to find out the maximum number of electrons fit into the main energy level using the formula 2n square. Right, for example, first level, main energy level, N equal to 1, then what number of electrons are fit into first shell called K? It is N equal to 1, indicating the main shell. Okay, I'll give you that. Here, how many electrons are fit into that main energy level or called as shell? So 2 into 1 square equal to 2. So maximum you are able to put 2 electrons into that. Maximum you are able to put 2 electrons into that. Then here, depending on the N value, you are able to know the main shell. That main shells are named by Niels Bohr only in his Bohr atomic model. If N equal to 1, it takes the main energy level or it is considered to be as K shell. First energy level is considered to be K shell. If it is N equal to 2, it takes main shell L and so on. N equal to 3, M, N equal to 4, N, and so on. So as many as you consider depending on your requirement. So K, L, M, N, O, dash, dash, dash. So you can consider that. Is it clear about principal quantum number? Everyone, just give me your response.